Nag Nagamani Sai is you?
Yes, sir.
Hello. Yeah. Where?
Nagamani Sai, what is your role? Nagamani Sai, what is your
Sir,
role?
already video is live now.
No, sir.
Renu, some Nagamani Sai, one girl just he joined. Hello? That's why no. Have you taken this link, Google Meet link? You are not visible. No, రవి గారు ఎవరైనా మన చూడండి రేణుకాని ఒకరిని మనం ఎలా చేయాలి ఎవరిని జాయిన్ అవ్వాలంటే నాగమణి సాయి యూ కెన్ లాగ్ అవుట్ ఐ థింక్ వాట్స్ యువర్ రోల్ ఐ డోంట్ నో నాగమణి సాయి
Okay, sir.
యూ కెన్ లాగ్ అవుట్ హలో ఇప్పుడు లాగిన్ అవ్వండి మీరు గూగుల్ మీట్
Shall we start, sir?
we will send the link to a few more also. Ravi, just Renuka, should we let in someone? This the Renu, the host, is trying to join. She's being asked to let in. Can we allow her?
Admitted.
Yeah, joined. Yeah, she joined. Yeah. Yeah, I put Renu.
Yes, sir. Now I am in.
Yeah. So can we share the new link, YouTube link to as many people as possible?
Okay, sir.
Renu, I will send the new YouTube link.
Okay.
Afterward, just you try to send to as many people as possible.
Sure, sir. Sure.
Not this Google Meet link.
Okay, sir.
Just a second. Yeah. Forward. Yeah. No. Once your introduction is everything is over, just you can try to pass on this link to as many groups as possible.
Okay, sir.
Maybe I think we are right now we can go, sir. Ravi sir, and then see them this way. Anyone else is there? Yeah. Abhinav ji, are you ready?
Yes, I am ready. So whenever you are, let me know. So
Yeah.
I will turn on your Google Meet, and we'll have to wait 15 seconds before you are live.
Yeah, on this, so Abhinav ji, this is something. The program is like this.
Sir.
Renu, the host, she will first give an introduction, and then she will ask me to speak introductory remarks, and after that, Renu will introduce you. After my introduction, you will introduce. Okay, Renu will introduce you, and then hand over the proceedings to you, and
Sure.
then you will make the presentation, sir. And then at the end, we'll have the question and answers. So Renu will note down, and Renu or Ravi sir will note down the questions which are asked in the comment section of the YouTube.
Right, sir.
And then finally, Renu will come and then she will propose the vote of thanks. Okay, sir?
Right, sir. Right,
Okay.
sir.
Thank you. Thanks. If you say yes, then Renu will start. Then if you say that
Yeah,
you are ready, you can say.
I think you can see on the YouTube we are live, so you
Yes,
can
sir.
see our all four of us over there.
Okay.
I'm using mobile network, so let us see how it goes. Yeah, please start.
Yes. Then you can start.
With due respect, I would like to start today's session on what we call is that one prompt engineering. Ladies and gentlemen, distinguished guests, Dr. Ravi Saripilla Garu, and our speaker today, Dr. Abhinav Dayal Garu. And I uh, welcome our Director of CITAM, Dr. M. Sesibhushan Rao Garu, to this meeting. And I welcome our HOD and all the enthusiasts of language and technology to today's language and technology online webinar on the exciting topic of prompt engineering. I'm A. Renuka, delighted to host this meeting before you all as your host for this virtual gathering, where we'll dive into the fascinating world of language models and explore art of science and prompt engineering. Firstly, I would like to hand over the virtual stage to our director, sir, to please address the gathering.
Thank you, Renika. Good afternoon, friends. The world is changing a lot, and then coming 1 or 2 years, we will see a lot many changes. All those who are observing maybe 2 3 months, maybe after the advent of this chat GPT in December 2022, lot many changes are taking place, and then this is going to accelerate, and then in the coming 1 or 2 years, lot many changes are going to take place. We are going to see this world, and then now to understand what are all these things and then how we need to prepare and all. This webinar is organized with the help of Dr. Ravi Saripalli. He is the Director Innovation GVP Group of Institutions. I thank Ravi Saripalli Garu for arranging this webinar. And the keynote speaker for this today's webinar is Abhinav Dayal. He's very experienced. Abhinav Dayal ji, I thank you very much for
Thank you.
accepting our invitation, and I thank the whole Vishnu Group, the principals, directors of, and the chairmen of Vishnu Group also for giving us an opportunity to host you. And then hope this will continue, and then in the coming days we'll have more. Uh, uh, Workshops in association with Vishnu Group also. With these few words, I thank Abhinav Gar, and then I hand over the proceedings back to Renuka. Thank you, Renuka.
Thank you, sir.
Thank
Thank you for addressing all the gathering who attended the meeting. Now I request Dr. Ravi Saripalla Garu to address the gathering.
No, I think Dr. Abhinav is the right person for handling this prompt engineering because he's enthusiastic and he's an AI expert. In fact, as you see that in the next few years down the line, probably I think prompt engineering is going to be the key for majority of the jobs because as I mentioned in my introduction, in introduction mailer, the world of opportunity is going to be shrunk into the four categories. One section is all about entrepreneurs who are actually going to build AI assistant, AI related apps. The second section is all about the people actually kind of tune these LLMs and MLMs and so on. The majority of the jobs would be on the prompt engineering side. So one who creates the best prompts, one who crafts the best prompts are going to be the future, and I'm sure I think those people would grab maximum opportunities. So to create a simple prompt, it is not that easy. Like how we are writing in ChatGPT is not the real prompt. So to learn more, I think today we have Dr. Abhinav. He's an expert in AI. He's actually building another LLM for another company, Korean company. So I'm sure I think he would give the best way of handling this prompt engineering and so on. So handing it over to you, Abhinav.
Thank you, sir, for opening the meeting. Before moving on to the next part of our session, Now I take it my privilege to introduce the profile of our chief guest of the day, Dr. Abhinav Dayal. Dr. Abhinav Dayal is the director and founder of Elegance Technology Labs Innovative R&D with the aim of enlightening individuals' intellectual and social intelligence. He is skilled in software architecture of MLOps, DevOps, algorithm design, natural language understanding, and machine learning. He is a professor of CSC and Dean Advanced Learning of VIT Bhimavaram. He has also been a professor and research coordinator and research at Sagar Institute of Science and Technology from 2014 to 15. He worked as a consultant at Lansing and senior software developer on various technologies like SharePoint, .NET, Flash, Silverlight, ASP.NET, C++, COM, JavaScript, and etc. He also worked as a technical support engineer at Wolfram Research on advanced mathematical issues involving many mathematical issues, problem solving issues. He did his PhD in computer science in Northwestern University and MTech from IIT Delhi and BE in Birla Institute of Technology, Misra. And he is also awarded with a gold medal. His projects also include Tech Track, Advanced Communication Skills for Engineering and Science Students, and Grammar Expert. Uh, Now I have provided a brief introduction about our chief guest. Now I kindly invite our speaker, Dr. Abhinav Dayal, to please unmute yourself, sir, and feel free to talk. The entire virtual screen stage is yours. If you want, you can please
Thank you,
share the
Renuka.
screen.
Thank you, Renuka. Uh,
Yes.
so welcome one and all. I hope you are able to see my screen of prompt engineering. So this is a very introductory journey that we will give into prompt engineering. And since I am speaking to undergraduate students of various streams and maybe from first year to final year, so we'll start with a little bit of engineering background of why prompt engineering, and then we'll move on to introducing the topic itself. So today's agenda will introduce first of all what are large language models, because those are the key building blocks that actually introduce this field of prompt engineering. Then we'll move on to fundamentals of prompt engineering. We'll discuss the basic principles and techniques of prompt engineering, and the more important, what is the process of prompt engineering and how it is different from the standard machine learning process, and how is it similar to that as well. What are the various challenges that you may face and the issues with AI ethics? We'll also see some of the tools, real world examples, and what's the future of this field. And we'll briefly see some of the advanced prompt engineering techniques, and followed by a final Q&A session. So if you people have something in the middle, you can use the chat to post your comments over there. So I have another screen where I'm looking at those chat messages, and I will be answering questions in the middle as well. So because I am on YouTube Live, there is a 15-second lag between what I am saying and before it reaches you. So if you ask a question, that will be quite delayed. So don't expect like immediate response. Maybe it may take 15 to 20 or 30 seconds or even a minute before a response can come to your question. So let's begin with introduction to large language models. So let us now think of a few common NLP tasks, and I'm sure you people are familiar with several NLP tasks. Like we can see some of the common NLP tasks, like we see machine translation, text to speech, speech to text, language translation from say English to Telugu and vice versa. And then we are working with information extraction. So given some data, we need to identify, okay, where are the places in this text, identify the names of the people in this text, identify the products which are being talked about in this, and so on. So those are named entity recognition. Then there is part of speech tagging, like finding where are the nouns, pronouns, verbs, adjectives in a text, right? And then there are question answering system, like all the chatbots, we see various expert systems, and question answering is actually a very, very broad field and mostly used field in NLP. And then standard, there are classification, for example, uh, like given reviews, telling whether what the sentiment of that review, whether it's positive, negative, or neutral, detecting fraud transactions, or detecting whether an email or a message is a spam or not spam. So many different kind of classification can also be done, right? So these are the various NLP tasks, and over decades, there are literally thousands and thousands of papers growing each and every task, like growing the field of each and every task. And what has happened that we can now summarize the basic process of machine learning, right? Particularly tuned to natural language processing. So first of all, as any machine learning process, we collect data, right? Relevant data that we have for our particular task. Say if we want to do sentiment classification, we'll have various reviews, and probably we'll also have humans label those reviews, whether positive, negative, and we will collect that data. That's supervised learning, right? And then we take that and we train a model. So I'm not sure if like many of you may or may not be familiar with machine learning processes, but a model, you can just consider it as a black box which has like just a mathematical function. That function takes input as, for example, for sentiment analysis, the text that you have given, and it outputs the probabilities of the three labels or classes, for example, neutral, positive, or negative, right? So that's a model, and from that model, once we take our data, train our model somehow to align and learn those mathematical uh, functions inside it, which are governed by something called parameters. Those parameters are just bunch of floating point numbers that gets multiplied or added with your inputs in multiple ways, right? So then we calculate the metrics, like how well our system is doing, right? So like we develop certain kind of loss functions like root mean square loss, or uh, you know softmax, or there are different kind of loss functions that we can use. And then finally we find the deficiencies, like is our model good enough? If the model is good, fine. If it is not good, we tune our parameters or maybe collect more data, and this cycle goes on till we improve our model, right? Now let's consider that's a standard machine learning process. Now since we are talking of language models or large language model, first of all it's important to understand what a language model is. So, for example, consider this sentence: the sun rises in the dash. So we all know the next word is east, right? Because already have trained ourselves since childhood that for this sentence, the sun rises in the east is a factual answer. So we have kind of a model in our brain. That model tells us, okay, what's the next word should be. So language model is simply an entity that, given some piece of context or text, what will be the next probable word that can come. So that's a language model. Okay, so you can see over here. So what is the probability I saw a cat on is equal to what? Like what will be the next word, right? And usually it takes certain Bayesian reasoning or probabilistic techniques over there, where I calculate probability of I saw as probability of I times probability of saw given I, probability of A given I saw, right? So it's conditional probability that we know in mathematics, that what is the probability of A given B, right? So we can multiply these probabilities, and then we can find what is the probability of this entire sentence I saw a cat on, right? So now if in my vocabulary there are multiple words like the, mat, and so on, I can try possibly filling the blank. I saw a cat on space, like what's the next word? I can try to fill all possible words and try to find the probability of that, and whichever gives me the highest probability, I will say, okay, that's the word I will pick. Okay, so it follows kind of this Bayes theorem and Markov property. I'll not go into detail, but basically Markov property says that if I have to see I saw a cat on a mat, I will see, and suppose I am using something called 3 grams. That means I will not go too much in the history. I will just go 2 level back in a history. So probability of, for example, if you say the third line over here, right? So probability of cat after I saw a, I don't bother about I, only say saw a, right? What is the probability of cat given the last 2 words? probability of on given the last two words. So simplifying our problem, right? And of course, it will not be as accurate as this part over here, but it still works, and mathematically it is a bit solvable, right? So without going into details, I will post some of the links that I used to prepare this material. This link particularly is coming from a very beautiful, course from a professor. So I will share that link as well in tools and resources. So we can, see this thing. Let's play this. So as soon as this happens, I sample all the probabilities, what can come. I am, so I was highest. Now I was there in glad, happy, right? Whichever probability is highest, I will, generate over there and so on, right? So we can actually, so now I'll use the last two words, was happy, and then what is the probability? Highest probability was of 2. So I'll put 2 over here and so on, right? So that's how we can generate. So if you have been playing around with, say, chat GPT and those kind of language models, when you can see it builds the text word by word, or actually to say more technically, token by token. Okay, it builds those things. So that's how it is doing it. Of course, the way it is estimating probability is not as simple as using a Bayes theorem, but it is essentially doing the same thing. Okay, so you can train this. For example, you can actually ask ChatGPT itself to train you on probabilistic techniques of a language model using Bayes theorem or Markov property. You can ask it to give a code in Python to take some text. Say for example, you can take some data of say children books, and then prepare language model out of it, and then you start once upon a time and give it blank, and you keep generating. It'll generate a story for you. Okay, so now, as field evolved, the neural techniques of language model became more prominent. So earlier it was LSTM and RNN, long short-term memory and recurrent neural networks. And recently, for last 4 or 5 years, transformers have really changed the picture and really brought NLP to a level which was never seen before. So in a neural network architecture, every word which we saw, like earlier in probabilistic, the word remains a word, but a neural network takes as input as some mathematical numbers or vectors, as we can see over here. So every token or every word, I will discuss, what is a token a little later. Every word is converted into an embedding. Embedding is its mathematical representation, and it basically says, can we create an embedding that somehow associates a meaning for that. So just to give you an idea, say for example, we have 3 dimensions. First dimension is whether the how powerful the word is, right? So it is good versus it is excellent, right? So there is more power in excellent versus good. How positive the word is, right? Good, bad, worse, like that, right? And maybe another dimension can be like how so we have positive or negative, we have the power, and we also can have, say, gender, is it feminine or masculine, and those kind of things. So we can add as many dimensions or meanings of a word and so on. And then suppose I give you a vocabulary of 20 words, and we ask 10 human graders to actually evaluate or give a rating from 0 to 1 for each of those dimensions. So 0 being, suppose we are giving positive, so or say -1 to 1. -1 means like it's negative, and 1 means it's positive, and 0 means it's neutral, like that. So everybody gives a rating. So for every word, I will have 3 numbers from -1 to 1, right? So that becomes a dimension, right? So now if you can visualize 3 dimensions, all words which are similar will be together, right? So like good, best, all of these are positive words. They will move toward the positive dimension more, right? So that's the intent of embedding. So like we as humans may not be able to come up with all the possible dimensions that the meanings of a word can take. So we have devised these neural networks, and we devise, say, okay, we want to learn about what 500 dimensions or say for example ChatGPT use probably 17,000 dimensions. And as the number of parameters are increasing, the number of dimensions also increasing. So how many different meanings we can take, right? For example, each topic can be a domain. Like what domain it is? Is it a scientific topic? Is the word belongs to a domain of technology? Is the word belongs to a domain of education or a social dimension? And then further by the company. Okay. So whatever company that word keeps, say for example, if I say the sun rises in the east, the sun and rises word is coming together. And the more often it comes together, the probability of them appearing together is increasing, right? So they are more related, right? So we learned those somehow with, using these neural networks. So all of these are initialized to something, sent to a neural network. Neural network predicts something. Like for example, if we send I saw a cat on a, each one of them is going to a neural network. Neural network creates some output. It goes through a linear layer that produces as many outputs or as many tokens as they are in our vocabulary, right? Suppose my vocabulary had I saw a cat on the mat, happy today, like that, right? So for each one of those words and the at, happy today, it'll produce one number. Whichever number is the maximum, say this was the maximum, I will pick that as the next predicted thing over there. Okay. So okay, so no questions yet. So moving on. Okay, so we can play this and see how it is actually working, the neural network. So I went over there and saw probability was high. Saw came here, then cat. So one by one it is predicting and it is going on, right? So that's what is happening when you send something to chat GPT. It will send your initial text over there. It will produce a next token and then initial text with the next token going back to the model, producing next token. So it generates one token at a time. It is happening so fast. And just imagine like what's the bandwidth of it and what's the compute infrastructure which is actually running that behind the scenes. Okay, so one of the key transformer of this was the actual transformer architecture, which transformed the NLP industry significantly. So it was a researcher at Google, Vaswani. He proposed this in 2017, and he proposed this encoder decoder architecture, which had the self attention, like a very beautiful mathematical model that could leverage the advantage of how, like, which tokens are paying attention to which in a sentence. So establish that context or relatedness. For example, the cat sat on a mat, right? So like who sat? Cat sat. So cat and sat are more related. Sat on what? On the mat. So sat and mat are also related. But cat and mat are not directly related unless there is a sat word in between it, right? So establish all these relationships. Now, this is a very simple sentence, but there can be more complex sentences, and then within sentences relationships, long context relationships, right? So it was able to do that, right? And as technology evolved, as people were able to add more and more dimensions and more bigger context sizes. For example, now GPT allows you to give up to 16,000 tokens and GPT-4 up to 32,000 tokens. You can give large history, right? And research is going on and even increasing that. So you can probably send an entire book and then, ask to analyze it or do something with that, right? So here there are encoder and decoder architectures that you can see. An encoder is something that takes input as text and codes it into some intermediate representation, and you can use it to do something. Say for example, you are inputting a review, and that review is encoded and you need to do three classes, right? So similar to this one. So review went here, some numbers went here, and the linear layer here has three possible outcomes: neutral, positive, negative, right? So that thing will come over here, and that encoder is sufficient. Whereas decoder is something takes that encoded information and decodes it and produces some output. For example, machine translation. I want to convert English to Telugu. So English is inputted in codes, and then the decoder takes what the English sentence was and also takes whatever Telugu is produced till now and keep producing the next over there, right? So all these GPT, BARD and all, they are only decoder only models. They are not encoding anything. They're only trained with decoder only model. There is no need to encode over here because they are usually for question answer or auto completion tasks. and they have been trained to do multitasking. We'll just discuss that in a brief while. But so we already discussed that when we do embeddings, similar things appear together, and there is this metric called cosine similarity because say cos 0 is 1, right? So if these two things are very close to one another, the angle between their vectors in the dimensions that we have created, the embedding dimensions, will be small. Okay. So represent meaning of each token. Why we are saying token is because in the vocabulary there will be many words, right? And it's really not possible for us to define the entire vocabulary and build tokens out of that because there may be millions of words. Consider general English, then consider domain specific English, technology and different fields, and then consider other languages as well. If we combine all of them, right? So a token is probably part of a word. For example, singing can be probably divided into two tokens, SING and ING. Now, ING can be a common token which can be attached to many other, swimming, teaching, right? So, so that makes like these distances together. Say, for example, if the distance between man and woman vector is this much, the king and queen vector will be this much. Suppose I say, if I say man is to woman, then king is to what? So all I can do is find the distance between man and woman and add that distance to king. I will arrive at the queen. Okay, so that was a beautiful, study that happened. Like this is word to vec and glove embedding that happened like around 5 years before. Okay, so prior to LLMs, so many different models came up. So that was the evolution of large language models that came up, starting with these word embeddings and then pre-trained embeddings. And you might have heard these words like BERT, Roberta, Albert, Cove, Elmo. So these all create pre-trained context-specific embeddings for these different tasks. And these were at that time relatively big, but not as big models. Like maybe few million parameters or up to a billion or 1.5 or 2 billion parameters, not more than that. Okay, but they were very helpful, and the research grew intensively, and that actually led to the growth of large language models, where people started thinking, what if we train a neural network of a neural language model on all the text on the internet, like all the text in the books, allow all the multiple languages for multiple tasks, like maybe it's a classification task, sentiment analysis task, a machine translation task, all of them combined with a similar strategy, right? And how many parameters that would be. And that's how it started growing. Like in 2019, Elmo was the first model that reached close to 1 billion parameters, like zero point 0.1 billion. Then BERT large came, then GPT-2 with 1.5 billion, then T5 with 11, then Megatron. Then GPT-3 was released in 2020 with 175 billion parameters. I mean, it was trained but not released to the public like that. It was there, but ChatGPT was not released. Like it was released just recently. Then Jurassic, Megatron, Palm. Now GPT-4 it has approximately 1 trillion parameters, right? So number of parameters that these models are growing in size over time and growing in accuracy and the capability of the tasks that they can do. Okay, and there is also another area of fine tuning this large language model for specific tasks. So rather than say, for example, using a GPT-4 for certain tasks, you can probably take a smaller model, say GPT-3 or maybe Palm or Megatron or T5, and train it for maybe only to process legal documents or only to process certain very small domain and fine tune it on those tasks over there. Okay, so how LLMs are trained? Very brief introduction to you. So, say for example, let's say different tasks, say classification task. So we will have the text between start and extract token. So these are specific tokens, like just like HTML tags, we can give a token, and each token, as you have seen, will have an embedding associated with that. So we'll have a start, then a text, and then a separator that says extract. Okay, and then it'll go to a transformer again, and the transformer will give a output which goes through a linear layer and a softmax which classifies, right? And we have supervised learning, we have the data, we train it back, and this transformer learns those embeddings, right? Similarly, entailment, right? Whether this thing is contained within this, like if this is the premise, does that premise support this hypothesis or not, right? Start premise some delimiter, like some delimited token. Similarly, similarity, like you have seen these models like SBERT and all. So text 1 and text 2, right? So this is also called, there is a very beautiful name for that, I'm forgetting that. Um so like twin model. So there are two models. Same model it is the same transformer is taking two inputs, text one, text two, and text two, text one, and then adding all of the like outputs of both the runs and followed by a linear, and then it trains back. Similarly, if you want to train a model to answer MCQ, multiple choice question, you give the context, you give the question, and and you give the answer, and you extract whether the model is giving A, B, C choice correctly or not, right? So people have trained the same model on multiple tasks, and that's how these large language models were trained, and they became very powerful models out there, right? So benefit of LLMs are a single model can be used for different tasks. You can fine tune the process, require very minimal data, and the performance grows with number of parameters, right? So modern generative AI actually can ingest a lot of data and generate info for specific tasks. So here, earlier, if you remember, we have to collect the data, we have to train a model, we have to do the metrics and all that. But now with LLM development, and actually, if we it's not possible for everyone to train their own large language models, because we don't have access to that much data. Even if we have, we don't have access to all the compute resources that actually are needed to train such a model, right? So you don't need an ML expertise. You don't need training examples. You don't need to train a model. The model is already there. But you will have to do something to extract what you need from that model. And that leads to the core topic of what we are discussing today, which is prompt design. Okay? So let's discuss fundamentals of prompt engineering. So if there are any questions still now, please post on the chat so that I can answer those questions. If anybody has questions, then I'll move on. Okay, so since there is a lag, I'll move on and also side by side watch the chat. Okay, so what is a prompt? A prompt involves instructions and context passed to a language model to achieve a desired task. Okay, so for example, you can ask, compose an email to my boss, mentioning that I am planning to take a vacation from such a such date, something like that, right? And then it'll do a very nice email, right? So you can now say, okay, change this email to I'm writing a friend, so use a more casual language than formal language, and it'll write another email with a formal language over there, right? So you are giving instruction for the task you want to do, right? For example, you give a review and say, can you please rate this review as positive, negative, or neutral? And it will give those kind of ratings to you, right? So that's what a prompt is. And then what is prompt engineering? Prompt engineering is the process of developing and optimizing prompts to efficiently use language models for a variety of applications. So you have a particular application. Say, for example, you are building an application for, uh, say, help people write academic articles. Okay, so then like people will be writing, say, academic articles, and they want to do something like what the next sentence should be, or what the citation should be, where should I cite something, and all those kind of things, right? So rather than having people research and do their prompts, the prompt engineer will actually decide what are the different use cases and what is the best prompt that I can give to a large language model such that I get the right kind of response. Okay, so there are different types of language models, and we should know that because prompting strategy varies from model to model. There are actually three, and more types are coming as companies like Microsoft, Google, and Meta are researching. So one is generic model. These are also called autocomplete models. Like for example, the DaVinci, Ada, or Babbage model in OpenAI realm. Those are autocomplete models. So they predict the next token given the context. The standard language model, right? The sun rises in the space. So it just continues and completes the text. So the prompting strategy would be different for such kind of models. Then we have instruct, like instruct GPT, that actually led to further dialogues. These two are related, instruct and dialogue. Instruct is a single instructions, whereas a dialogue actually not only responds to the current instruction but also take into account the previous dialogue messages that have happened so that you can uh, you know uh, do better over there. So here, the training process was different. Something called RLHF, reinforcement learning with human feedback, was used. So the chat model was asked to do a particular task, it did that task, and then the response of that model was given to human experts, and they rated further on different attributes, how well the task was done, and that was converted into a loss that trained the LLM further, and so on and so forth. Okay, so that's how these models were trained. Actually, huge investment was done in training these models. Okay, let's move on to design principles and techniques for our prompting, how to make an effective prompt, right? So to make it effective prompt, first of all, you need to know that it should be very clear and concise language, right? So you have to keep the prompt easily understandable and straightforward. Okay, don't make it complex. So for example, instead of give information on the medical condition, symptoms and cure, right, you want to keep it simple. Describe the symptoms and treatment for pneumonia, right? So you need to give very specific information over there and keep it as concise as possible. Then the second one is understanding the target audience, right? So you have to tailor prompts based on the knowledge and expertise of the users, because you are building applications for certain audience. So for example, if you want to explain photosynthesis and it is for students, you will write explain photosynthesis in simple terms. But if the response was meant for a scientist, you will say discuss the role of chlorophyll in the light dependent reactions of photosynthesis, right? The more specific, more detailed question that you would form, right? And one beautiful thing about large language models is that they are domain agnostic, in the sense that because they are trained on all kinds of domains, you can ask a legal question, a medical question, a sales question, and it probably have understood, now when I say the word understood, so don't think that it actually is consciously understanding things. It has mathematically modeled those things so that it gives high probability for when you for that kind of answer to flow through. So just imagine, it's essentially the same thing going on as we discussed. The it's going through a neural network, giving the probability of the next token, and so on and so forth. Okay. The next is defining a specific task, right? So you have to clearly indicate the desired outcome and what information you need, right? So you don't be vague. We can, like, for example, discuss the impacts of climate change, right? There are so many impacts. How many to discuss, or maybe what specific aspects of climate change you are, referencing to, right? So be very specific. List three primary effects of climate change on the polar ice caps, right? So you will get a much better response than giving a very vague output. Then finally, like encouraging diverse responses, right? So you can actually, keep it open-ended. What are some potential effects of artificial intelligence on society? Or say, for example, what are the negative effects of artificial intelligence, right? So you can encourage diverse responses by modifying, like you can say, what are the positive effects or what are the negative effects, or keep it open-ended. Either give positive or give negative, right? So now let's discuss of some of the techniques how we can actually build a prompt. So first of all, we have to focus on the user intent. So consider the underlying goal of the user when designing prompt, right? So for example, user intent is to help with planning a party, right? And down the line, many of you may become prompt engineers or use prompt in developing prompts for building certain applications rather than just using ChatGPT for your own use. So here you need to understand what the intent of a user. And then when you know the intent, you can give a prompt, like provide a checklist for organizing a birthday party, right? You don't just ask like, can you help me planning a party? No, you don't do that. You actually give very specific prompt to it. Okay. And then experimenting with different phrasing. For example, you can explain the process of cellular respiration, or describe how cells produce energy through cellular respiration, right? So you have to test multiple prompt variations to find the most effective one. And it's not that you have to try hundreds of them. You will get within few options, you will get a sense of how and what kind of response you are getting for your particular task, right? Then prioritizing action oriented prompts. So instead of saying like what are some marketing strategies, you can again be very specific and have it more action oriented. Like list 5 effective marketing strategies for small business. So you have given this keyword effective over there. This effective keyword is very important because you are asking it that I want it to have an action of being effective, right? And you have to build the context, right? So without context is describe the economic impact. Economic impact of what? Right? So that context is important. Analyze the economic impact of COVID-19 pandemic on hospitality industry, right? So this is more specific. Then incorporating examples. So we will discuss zero shot and few shot after some time in the same talk today. So we can either ask without examples, write a haiku about nature, or you can give like what kind of haiku you want. So follow the 575 syllable pattern like old silent pond, the frog jumps into the pond, splash, right? So like it's kind of a joke. So silence again, right? So you can give more examples to it. Similarly, right, like you can continuously refine prompts based on user feedback and performance, right? So like you can say initial prompt, what is your favorite color? And refine prompt can be what color do you find most visually appealing and why? Okay, so that is more specific. So there is a question from Karthik. How does choice of prompts affect the performance or behavior of a model? Right. So the performance and behavior is specific to the task that you are doing. Right. The model is not going to change here because we are not training the model. We just need to, because it's already pre-trained on multiple tasks, the large language model, right? That our case is how to utilize the model with better prompt engineering, right? So the choice of prompt affects the performance of the task that you are doing, right? So we saw many examples already in this, like 4 or 5 points that we discussed over there, right? The more precise you are, the better response you will get, right? We will discuss some like we'll do some hands-on and we will show some prompt techniques as well, right? So let's so if it question is answered, just say yes. Otherwise, I can further discuss the answer over there. Let's move on. So let's discuss the process of prompt engineering right now. So we know the design principles. Let's discuss the process. Okay. So overall process is like you have to first as you have to understand the problem, and then based upon the problem that you want to solve, you have to draft those prompts so very clearly, and then you test your prompt. So it's related to the question that Karthik asked. For example, you can actually create your own data set, like not very big data set, maybe 150 like that. Create your own data set that for this kind of input, I want this kind of an output. Say, for example, you want to extract certain information, say, like named entity recognition, right? So, given text, you want to extract places in the text, right? So, your input is a text and output is number of places, right? So, you can actually draft a prompt for that. And given the output, you have to have a testing strategy that tests whether the output of the language model given the prompt matches the data that you have, and you analyze your results. And if the results are satisfactory, fine. If not, you iterate and refine. You change the prompt, try again till you meet your results. And then there is ethical compliance. We will actually look into that briefly. So yeah. So first of all, let's begin on understanding the problem, right? So we have to really identify the context and requirement of the specific task, right? For example, design a prompt for a movie recommendation system based on users' preferences, right? So we have to understand the problem. Like what's the goal over here? So we have to clarify the goals and desired outcomes of the AI model. So goal is that we want the AI model to generate personalized movie recommendations. So this should be very clear to us. So similarly, while drafting the prompts, we have to write a variety of initial prompts based on prompt understanding, and then incorporate those design principles we just discussed, and maybe we can test them as well as a step 3, right? For example, for the problem at hand, like movie recommendation, we can draft certain prompts, like suggest a movie similar to user's favorite movie. Now this is very specific question, right? So we are asking a similar movie to this movie, right? List 3 movies that fans of this movie may enjoy, right? Because you want a recommendation. What movies should you recommend to someone who likes this, right? There are different prompts that you have created, then you can test. You can test each prompt with various movies as inputs, right? And then you can evaluate AI generated recommendations for relevance and diversity, right? So one way of evaluation is user testing, right? So for example, you give a recommendation and you take live what users whether they really liked it or not, or you can get data from Amazon Prime or Kaggle or Netflix, where they might already have a lot of data on what recommendation people liked and what recommendation people not like based upon their watching history, movie watching history. So what are the types of prompts we can use? Uh, so there are no there are types of language models, and based upon the task, the prompt will change. So there is no specific types of prompt, I would say, because prompt is very specific to the task and the problem at hand. So let's discuss the second, continue with prompt engineering process. So after we have tested, we want to analyze the results, right? We identify the patterns in the behavior of the model, assess potential issues. Are there any biases? For example, maybe the model is biasing to certain, genre or certain release years, or it does not have that much diversity, right? Or maybe the model is biased towards like some popular blockbusters, right? So then we will iterate and refine, right? For example, if the analysis was that the genre was being biased, then we say suggest a movie similar to this from a different genre, right? So we give that, and then it will clearly give a different result. So list three lesser known movies, right? If it is biased towards blockbusters, three lesser known movies that fans of this may enjoy, right? So what underrated movie should you recommend to someone who likes this one? So we are asking for an underrated movie rather than super hit or something like that, right? So we can design prompt based upon, suppose the user says, no, I don't like that. So we can do next set of recommendations based upon that. And then we finally evaluate the final performance. We validate if the recommendations are more usable and it meets the desired outcomes or not. Okay. So let's, discuss some of the challenges that are faced. And before that, we will actually do some little bit of a hands-on. So let me bring in. So one of the tool that you can use to try with prompting is um, this GPT Playground, OpenAI Playground. So here, for example, um, I want to try a few prompts. So we can try different models over here. So see, there are different type of models here. Complete, the autocomplete type models. This is the chat based models, and these are specific models. Like this is a fill up the blank kind of model, right? So this will, like, we are writing to insert, right? So it'll fill up the blanks over there. Similarly, there are edit models which will actually edit the text. For example, you want to edit it to fix the grammar, you want to edit it to move to a different style or something like that, and there are different models for each. Okay, so we'll go with, say, for example, chat model, because the most popular and the most popular model is GPT 3.5 Turbo. Recently, they released the 16K, and they, of course, have the GPT-4 over here, and GPT-4 with larger context that you can give, like more than 32,000 tokens you can give over here. We'll pick this one for now, right? And let's actually, see a model. Uh, let's say I'm copying pasting something. So I'm giving a text here, and the text is this, right? We are giving an overview of a product like a chair, right? And based upon this overview, so we will give the overview, and let's just give it for now, and we'll adjust the prompt later on. Let's give this, and then actually we need to be more precise. So usually one of the best strategy is to, whatever input you are giving, give it in some kind of delimiter. You can use triple backticks, you can use triple quotes, you can use less than, greater than brackets, and so on. Why we use triple ticks are usually triple back ticks are not there in actual text. So it's very specific, right? So now we can say that um, your task, like, and copy the full thing. Your task is to help a marketing team create a description of a retail website of a product based on a technical fact sheet. Write a product description based on the information provided in the technical specifications delimited by triple bracket. And we say technical specifications, right? And we just go submit, right? So it does that. It's quite huge, introducing this chair, part of a beautiful family of mid-century inspired office furniture, available in several options. Comes with plastic bag, constructed with 5 wheel, right? So it's great, it's good, but it seems to be like it appears to be too long, right? But we want it to be short, right? Because you know it's going to be in a flyer and nobody reads so much. So we want to change this prompt. So we will change the instruction now to this, right? The description is intended for write a product description based on information provided in the technical specification deleted by triple backticks. The description is intended for furniture retailers, so should be technical in nature and focus on the materials the product is constructed from, right? Suppose it was going for retailers. At the end of the description, include every 7 character product ID in the technical specification. Use at most 50 words, right? We have given very precise and specific instructions. We now submit it. So it did what? At most 50 words. At the end, it added product IDs, what we asked for it, right? And it is focusing on the materials, right? With options for full or plastic upholstery and armor. The chair is constructed with a 5 wheel plastic coated aluminum base made with high quality materials, right? So we did that. Okay. So instead of that, if we want to focus on something else, we can focus on something else as well, right? So suppose I want to convert it into an HTML, right? So my task is to take this description and create a web page out of it, right? So we can actually modify our prompt and ask it to do something like this. Yeah, the prompt is big, but that's prompt engineering. And the same thing will be used over and over again. So we can code these prompts and use ChatGPT API to do repeatedly for these kind of tasks. So your task is to help a marketing team create a description of a retail website of a product based on technical fact sheet. Write a product description, blah blah blah. After the description, include a table that gives the product dimensions. The table should have 2 columns. In the first column, in the second column, do this, format as HTML, and so on, right? So now let us see what output it gives. It gives me HTML. So those of you who are familiar with HTML, it is giving me a table, right? It is giving me the heading, the paragraph and the description, and with heading and a table of width, depth, and height. Okay. And along with some style information as well, the CSS over there, right? So this will just work. So you can get like head start for the task that you want to do, right? So similarly, you can, so this is like iterative, it's a process. Iteratively, we have refined our prompt to match our needs, right? So similarly, say we want to do some summarizing task like text summarization over here. So let us take, let us take let's put in triple quotes, and then we ask it to review this. So our prompt is your task is generate a short summary of the product review from the e-commerce site given above in triple quotes. Summarize the review, summary of product review in 30 words from, okay. Now we submit that, right? Soft and cute panda plush toy with a friendly face arrived a day earlier than expected, small for the price, but loved by the recipient, right? But this is fine, but we want to give something like for the sales team, right? Or say for the shipping team, say for example, you task generate a short summary of product review in 30 words from e-commerce site given above in the triple quotes. The review should be helpful for the shipping team to improve their services. And we submit. Okay, it starts with shipping details. The product arrived a day early, but for the price paid, the Panda plush was toy. Shipping team should ensure customers get value for their money with a bigger size. Right? So we can, modify our prompt based upon our needs. Right? Similarly, like if we have to infer certain thing, like let's delete this and delete this, and let's add a message. Let me see if there are any questions. So one question. Does a good grip on language affect the quality of the prompts we make? Yes, Prasida. Good grip on language is very important, and you need to know how to reword it and things like that. But given that, we will discuss some advanced prompt strategies that are used to actually help learn a better prompt, even if you don't have a good command on a language. But it does help. So Jayashree madam, I have a question. I use ChatGPT for generating MCQs for my subject. I see wrong answers many times. Is it extracting the questions and corresponding answer from any storage? Can you explain the process? Okay, no, it's not extracting from any storage. As I said, it has understood, and when I say understood, it has this big set of parameters that encode all the literature it has been trained on, right? And when you ask a particular question, it is just doing that completion, right? Suppose you ask, write an MCQ for, like we can ask here, write five, like write three MCQs for testing skills on Python programming language for a sophomore. Okay, and then we submit that. So it gave these three questions to me, right? Where it did not give me answers. So now I say I want to get the answers. After each question, give the answer hint. Okay, what is the correct syntax? So it gives that adding an integer string, right? So now there are many ways to give a better prompt. Like you can suppose you are getting a wrong answer or wrong answer hint or a wrong option or something like that. It's very difficult to ensure that it will always generate the right kind of question, but you can try to make it closer to what you want, right? So you can give like ensure that the answer hint is correct, right? So you can give some of these prompts, but like language models, they can do something, but they cannot do everything. Okay, so there need to be, say for example, if an application you are building that generates MCQs, what you can do is you can get a user feedback. If the user gives that the question is wrong, then you can ask ChatGPT that this question is wrong, can you please correct it? And it'll, after that, it will correct that question. So, yeah, we were here. Okay, we'll finish soon. We're almost done. We'll just, okay, there is a review and I want to analyze the sentiment. So, this is the review in triple backticks again. And then I'm asking about what is the sentiment of the following product review, which is delimited with triple backticks. Submit. Sentiment of product review is positive, right? Now, if I want to give the answer in a single word, then I submit it. So I get the answer in a single word, positive, right? So similarly, there are many tasks you can do with it. So we will move to our presentation back. Let's discuss some of the challenges, right? So some of the challenges that you can actually have very vague or ambiguous prompts, right? For example, write about a random topic. So again, so we should not give vague and ambiguous prompt. We discussed that, right? Because we need to emphasize the need of the clarity and precision in prompt language. And we should not use overly complex language because it's very difficult to understand even for a common man. So, for example, provide a comprehensive analysis of the symbiotic correlation between intrinsic motivation and ramifications of external reward systems. It's too complicated. One has to read it multiple times to understand it. So, keep things simple. Discuss the relationship between intrinsic motivation and the effects of external rewards, right? So keep things simple. Then it's easier also. One need not have that much you know understanding of the language over there. So okay, Dr. Ravi is asking, can you write a code generation prompt? Yes, I'll do that just after this section is covered. So unintended bias, sometimes there are biases. For example, describe the characteristic of successful CEO. And sometimes it may be gender biased because many of the CEOs are male. So the solution is describe the skills and qualities that contribute to success of a CEO. So we are clearly saying the skills and qualities, and we are not biased about the gender, considering diversity in leadership styles, right? So similarly, like lack of response diversity. So for example, write a story about a person going to work. We can change that, write a story that involves a unique and unexpected event happening to a person on their way to work, right? So we encourage diverse and creative responses in the prompt over there, right? And when it comes to ethics, it's very important that we design prompts that avoid such bias. We design prompts, like we test our prompts for fairness and inclusivity, right? I'm going fast. We keep user privacy and data protection in mind, right? So data collected is anonymized and securely stored to protect user privacy. We make sure that we can we collaborate with multiple people who can actually give us that feedback. Hey, this is not right. We can prevent misuse of AI systems. Like a lot of AI can be used to do spamming. Many wrong kind of news articles, wrong emails appear more realistic, right? So you more of spamming like that may appear as real. So we should avoid those. And we also should we have transparency in AI communication, right? If you have generated a message that is completely generated by AI, probably include that this was used by this email was generated by an AI or something like that, right? So before delving into tools, let us actually answer Ravi sir's question about writing a code over there, right? Say for example, I want to write a program to find GCD. So write a Python program, program to calculate GCD of two numbers, then submit. Okay, so now it is giving me that program GCD AB, if B is equal to 0, return A, else GCD B A percent B, right? So it gave me that function over here, right? Say now, for example, I copy this code, I delete this. If I say if B is equal to 1, I made error in this program. Is the above program or I correct? Submit. It's saying yes, the program is correct. It uses recursion to implement. So it is saying yes, right? So, but now if I say the base case is when b is equal to 1, is simply a, right? But it's not. It should be 0, right? So when the above program fails for GCD 2, 4, because 4% 2 is 0, right? So return G equals to is 0, return A, and then gives divide Y0 error. Identify the problem and correct it. Above program to calculate GCD of two numbers. Okay, let me delete this and submit. Okay, so now it identified the error. The problem is that if b is equal to 1, then the function will return it without checking if b is equal to 0. In that case, GCD 2, 4, after the first iteration, a becomes 4, b becomes 2. In the second iteration, a becomes 2 and b becomes 0, causing a divide by 0 error. To correct this, we can add an additional base case or so, right? So now still this program is wrong, right? So now I can say is case b equal to 1 needed? No, it's not needed, right? So basically, like when you use GPT and all for writing code, this is a very simple code. So you don't expect that it will give you the fully correct and don't just believe in it. It's not that AI can code for you, but AI can be a very helpful assistant in making you more productive if you understand what you are writing and you ask the right kind of questions. So here we had a problematic code initially did not understand. So we asked like what kind of error I am getting. So it corrected it and analyzed it correctly. And then when I further felt that this is not needed, but I'm not sure, so I'm asking, and I read the response and try to understand. I just don't believe it. I understand. Okay, it makes sense and it helps me. So I move ahead and create this final code over here. Okay, so another question. Suppose we write a prompt about a particular topic and the immediate next answers are for the prompts automatically gives answers to that topic without our mentioning about it. What happens here actually? Does it keep record of past response? Um, the immediate next answers for the prompts. Yeah, that's fine because see, it's a language model, right? Suppose I just write the topic name and don't give it an instruction, right? Say pros and cons of internet, and then I submit this. So it will just start to complete that essay, right? Because it is trained for those kind of things. It'll just do that. You don't have to ask like write an essay on that. So, but if this response is not very helpful, you can iterate your prompt to make it more helpful for you. Okay, so tools for real world examples and the future. So there are many tools. You can use ChatGPT, Playground. You can use Bing. Bing has give you access to GPT-4 at least for a brief use every day. Bard is open. You can use OpenAI Playground. Right, there is very nice this GPT tools that compares between different models. There is a collection of this promptbase.com. You can get some idea of the best prompts, but there is nothing you cannot say there is something like a best prompt out there. As I said, prompts are for a particular task. As the needs of the task change, the prompt will change. But people have given certain of their prompts that work for their use cases, so we can learn from there. From there, right? Similarly, there is this course on ChatGPT prompt engineering on deeplearning.ai, a free course. You can take that. Very, very good course. In fact, some of the examples I used today was from this course. There are other courses, more advanced courses of W and B. Like WAND-B is for analyzing the training of your models, and actually OpenAI used WAND-B's tools, and they have some beautiful courses. If you are wanting to develop LLM-based applications, you can go in over there. And there's a very good repository on a prompt engineering guide on GitHub. You can look at that as well, right? So real world examples are many examples that you can see. You can build chatbots, you can build conversational AI, you can generate content, you can summarize content, you can have sentiment analysis, right? You can do data analysis. For example, you can give an Excel sheet, like copy paste the table and say, can you analyze it for me? It'll do that. It can answer questions. You can build grading systems. So a lot of like every day new startup is coming in Silicon Valley and all over world on these, systems. So recently, one startup without any without any just for an idea, they recently raised $113 million funding in 7 days itself. So one of, like a history in funding. So, like we can, as we advance in future, probably we can see more advanced prompt design techniques. We can probably integrate with other AI ML models, right? We can adapt to evolving different technologies out there. So just briefly, like there is something called zero shot prompting, where you just ask the task and it does that. Like translate the following English text to French. Hello, how are you? It'll do that, right? But sometimes it does not give you the like in the way you want. So you can have a few shot prompting. So few shot means you give few examples. So you give example one, English hello, friend bonjour, English goodbye, French au revoir, English please, French s'il vous plaît. Right? You do that and then you ask translate thank you into French and say merci. Right? So you are giving certain examples and you are asking it to then do it. So it gives it more context and can do it better. These are very initial basic techniques that all of you can try. Then there are certain advanced techniques which probably need more of a discussion, like chain of thought, tree of thought, and all of these are there to help like resolve some of the problems. Like for example, in reasoning, something is not good, right? For example, if I ask a model to solve a mathematical problem, it'll probably give it a wrong answer. So we can do a chain of thought. We can ask it to do step by step, or we can give some initial steps or hints to it, and so on and so forth. So time is not there to discuss those things today, but you can look these things up. And there is something very important called RAG, like retrieval augmented generation. There is this site called perplexity.ai, which is a new search engine. Bing also is doing that. Suppose you ask on Bing search something, Bard does that. So it's like these chat GPT models were trained what in 2021, and after that recently, every few months they are retraining them. So once I have trained the model on certain data, it only knows that data, right? Say for example, you ask for latest news from ChatGPT, it will not know that because it is not trained upon that. Okay, but then these retrieval augmented generation and those kind of knowledge prompting and all, they first of all retrieve. So for example, given your query, say for example you are asking what like who won the cricket match that happened yesterday, and it does not have the knowledge over there. So it will ask ChatGPT, for example, a React kind of style, that do you have sufficient information about that? If not, it will like give me a query that I can do on Google or Bing and get the results. So it will get those results and then feed those results. Now with these results and this question, do you have sufficient information? If yes, go ahead and answer. Right? So a lot of work is being done on retrieval augmented generation and React style of prompting. So there are so many of these. You can go into this GitHub uh, thing I mentioned over here, right? I'll share this link in the video uh, also, right? So that's it. So any questions? There's some more questions over here. So Prasida, yes. So the model does not keep a record of past responses. It is doing it from the mathematical model, and if you need any new information, you have to pass that information to the model. So they keep the records and generate. Once you log off, that thread goes off. Is that right answer for the above question? Well, ChatGPT is a chat-based model, so it keeps a record or like the history of whatever it can from like few messages before. But if you are asking like earlier, like you just add a topic and it writes that topic, then no, it does not keep a record of those kind of things. So, no, her question is not a few shot prompting. Few shot prompting is about when you are giving certain tasks to do. Say, for example, let us say over here, say what is the temp? This is a question which you'll not know. Temperature of California today. Do you think it'll answer? Let us see. I'm sorry, as an AI language model, I do not have access to real-time weather updates. Please check a weather website or app on current temperature in California, right? So it is trained for that and it is doing a good task at that, right? But you can build systems that will actually ask and connect to a service that you know, right? So few short prompting, let us give an example of that. Say, create a story between Ram and Sham. who are friends, two friends in school, and they have met after 5 years. Right? Submit. So it's building a story, right? A big story it'll cook up and it'll build, right? But we want to it in a conversational style. So start like this. Ram, hi, are you Sham? We were in the fifth grade together. Long time. Um, it's you. See again. Oh, it's really small. Right, like that. And then we submit that. Okay. So now it will further story. Ram and Sham both smiled as they hugged each other. They were standing in the middle. Sham asked, "What brings you here, Ram?" Right? So we can further ask, continue in this conversational style. Submit. So now it's going conversational style, like Ram Sham. So right. So I've given this few short example to it, how to write, and it is giving Ram. Yeah, it's amazing how time flies. What have you been all these years? Sham. Well, after school, I went to college. It's building very realistic stories over there. Okay. So you can do a lot. You can write poems about it. Like you can ask it to write a poem on, let's say, engineering college. Let's say what it writes. It could have a very beautiful poem. Amidst the hustle of the city lies the college of great beauty, the place where young minds gather in pursuit of knowledge and wonder. Right? It's doing that. So you can write in the style of William Wordsworth. Right? So it's writing in that style. In the lofty halls of learning where engineering minds do soar, a college nested every yearning for students to explore, like that, right? So a lot of fun you can have with this, but don't use it for spamming. Okay. Any other questions? Anybody has? We went a little bit over time because we started a little late, but I guess I took 1 hour of time.
Sir Abhinavji, what are the job opportunities available for these prompt engineers? It is saying that a new category of opportunity that have arisen because of this AI, advent of AI.
That is true because now what is happening is a lot of startups are coming. Earlier, this kind of uh, you know outcome from a natural language model and all was difficult for a company to come up with. Now people have very like not so far very quick access to some a very powerful tool that can do a lot of things. So a lot of startups, a lot of things are happening in the industry, and people have to do is to do right kind of prompts to build better solutions for their customers. So it's evolving now, and since most of these startups are in the US, so there is more demand over there currently, but gradually this demand is going to grow. But as I said, it's not just like prompt engineering is something, it's a process people have to learn. Still, people have to build systems. They have to learn the art of machine learning, art of data collection, art of building their benchmarking, finding the right kind of matrix, how to evaluate, right? And as newer and newer practices, a lot of research is going on in this domain. So people have to be abreast with those techniques and keep trying those kind of things and improvise over there. So if we can give better value to users, more businesses will grow, and that's where these opportunities would come in. That being said, other than startups, I don't see currently many job opportunities, at least immediately available in India. But definitely, there will be a lot of scope for internship in this kind of domain. And a lot of people can also create or come up with ideas and build their own startups, at least explore building products with these technologies out there. But definitely machine learning is becoming easier. Now we have only shown text, but people are coming with models with very large models that can work with audio, that can work with videos, that can work with images. So the core development of like a lot of research that was done earlier in over decades is now getting like in a very concise way, but in a very large models. It is coming as services offered by these large players out there. So the machine learning industry would either use those kind of models and build applications on top of them where prompt engineering would be useful. Now it is only text-based prompt engineering. Gradually we will say audio and image or video-based prompt engineering as well. So for example, one can record an initial video and say complete this video, right? Or one can just start singing in a particular note and say complete this note, right? Or playing an instrument and then complete that thing over there. So more of those kind of things also would come in different domains. Then when it comes to multiple languages, like as it evolves, for example, ChatGPT is not very good at Hindi. It does, but it's not very good at that. Similarly, many languages, Indian languages, it will not be very good at. So a lot of scope of research and development and products out there as well. So engineering domain prompts in future, Dr. Ravi Saripalli is asking. I'm not sure what you mean by this question. Engineering domain prompts in future. If you can explain that a bit more, I can answer, try to answer that. Any other questions?
Yeah. Okay, sir. If there are no other questions, yes, we ask Renika to propose vote of thanks, sir. Is it okay, sir, Abhinavji?
Yeah, please.
Yeah. Renika, please propose the vote of thanks.
Yes, sir. As the webinar on the prompt engineering comes to an end, I would like to close this. It's my privilege to extend my vote of thanks before we conclude this enlightening webinar on prompt engineering. I would like to thank a speaker for taking valuable time and expressing his entire like in-depth information regarding the prompt engineering and all. It's really useful for all the students as this is the booming topic, one of the advanced topic which nobody can get the resources, where we had the resource person who helped a lot today. I would like to take a moment to express a heartfelt appreciation to everyone who had made this event very successful. Thank you and have a good day.
Thank you,
Thank
sir.
you,
Thank you
everyone.
all.
Thank
Yeah,
you.
thank you
Thank you
so
very
much, sir.
much.
Thank you.
Thank you, sir.
Thank you. Okay. Bye, everyone. So I've ended the stream.